Hello everyone, in this presentation we will discuss statistical quality control, which is an important concept in industrial statistics, and we will understand why quality control is necessary and what causes variation in products and how control charts help industrial maintain consistent standards. And these concepts are widely used in manufacturing, healthcare and service sectors. So, introduction to statistical quality control. Statistical quality control is a method of using statistical tools to monitor and to control production process. The main idea is to prevent defects rather than detect them after production. The focus is on controlling quality during production and not inspecting finished goods afterwards. For example, in a car manufacturing company, instead of checking each car at the end, SQC helps ensure that every stage of production is in control so defects do not occur. This improves efficiency and reduces waste. So here comes what are the important matters in SQC. So the three main qualities are consistency, efficiency and trust. So SQC is very important in industry because it ensures that products are consistent in quality. It reduces the number of defective items and minimizes production costs. For instance, in a pharmaceutical company, maintaining quality is critical because even a small variation can affect human health. SQC ensures that medicines meet strict quality standard. It also helps build customer trust and improve brand value in competitive markets. Need for SQC. In large scale production, variation is unavoidable. SQC detects changes at early, enables corrective actions at quick, supportive process stability and reduces dependence on final inspection. So the next topic is causes of variation. So variation means the difference between the actual product and the desired standard, not desired standard. No production process is completely free from variation. For example, let us take textile industries. The color or thickness of the fabric may change slightly. So understanding the cause of variation is important because it helps industries decide whether the process is under control or need the corrections. So there are two types of variations, and the first type of variation is chance cause and the next one is assignable cause. So chance cause is a natural type and unavoidable variation. These occurs due to the small factors like environmental changes, machine vibration or slight difference in raw materials. For example, in a bakery, slight differences will happen in oven temperature or ingredient measurement. It may occur these two types of variations, but it not changes the overall quality of the product. These variations are random and are always present in a stable process. And the next one is assignable cause. Assignable cause are due to specific and identifiable problems. These include machine failure, human error or poor quality of the raw material. For example, if a machine in a bottle is manufacturing a bottle become misaligned, all bottles may become defective. Unlike chance cause, these variations are serious and must be identified and corrected immediately to avoid production loss. So the next one is Shewhart control chart. So Shewart's control chart are graphical tool used to monitor the performance of a process over time. These helps distinguish between normal variation and abnormal variation. For example, in a call center, control charts can be used to monitor the overall call handling time. If the time suddenly increases beyond limits, it indicates a problem. Similarly, in manufacturing, they help to detect when a process goes out of control, so the corrective action can be taken quickly. So the next one is key terminologies. There are three types of terminologies. Most important specific limits are here, and the first one is specification limit, and the next is tolerance limit, and the last is control limit. So specification limit are set or used to identify the customer or a product designed and define acceptable quality of the product. So specification limit is the acceptable limit. So the next one is tolerance limit. So the tolerance limit indicates how much variation is allowed in a product. It is a permissible variation in the product characteristics. And the final one is control chart. Control chart is statistically determined limit used to monitor process stability. And the last topic is 3 sigma limit and warning limit. So 3 sigma limit in control limits, often we use 3 sigma principle, where most observations fall within 3 sigma standard deviation from the mean. So the three control limits are upper control limit and the control limit, and finally the lower control limit. If the points fall above or below the upper control limit or lower control limit, it is said to be out of control. So the values we are used in quality check, the values must fall within these control limits. So if the points fall outside the control limit, it is said to be not a statistic, the product is not in control. So the next one is warning limit. So warning limit at 2 sigma act as early signals of potential problem. For example, in a soft drink company, the quality filled in bottles must be consistent. If the level crosses control limit, it indicates a serious issue that needs immediate attention. Thus, control charts helps industries maintain quality and prevent defective effects.